This video is the start of Chapter 4, Regression Analysis, exploring associations between variables. This video is going to cover sections 4.1 through 4.2, and in section 4.1, we're going to visualize variability with a scatter plot. I'm going to show you how to create a scatter plot with Google Sheets, and then we're going to investigate the associations between the variables. Okay, so what's a scatter plot? Well, it's a primary tool for examining relationships between two numerical variables. Cannot be categorical, has to be numerical, and two of them. So sometimes it's also called bivariate data. And each point in the scatter plot represents one observation, and it's usually created using technology. We're going to be using Google Sheets again. If you were to create a scatter plot by hand, yeah, it's doable, but if you have like a whole bunch of data points to plot, it's going to take a long time. So usually it's done with technology. Okay, so up until this point, we've been describing numerical data sets with shape, center, and spread. So with scatter plots, we're going to not use shape, center, and spread, but it's super similar. Instead, though, we're going to use trend, strength, and shape. Trend is kind of like the center, and you'll see why later. Strength is kind of like the spread, and shape is the general shape of it. So from now on, for scatter plots, we're going to do trend, strength, and shape. Okay, so let's first discuss trend. This scatter plot right here shows a positive trend. So it's showing that as the car gets older, the number of miles driven increases. So you can see that it's positive, right? Because it's going in kind of an uphill direction. And also each point on the graph represents a different data point. So for example, let's look at this point right here. That point, that car is 10 years old. And this car has been driven, maybe I would say about, 40,000 miles. So each point has an independent variable that correlates with a dependent variable. So it's called dependent because the miles driven depends on the age of the car. Okay, so let's look at another graph. And in this one, we're talking about literacy rate and total births per woman. So this is showing that the question would probably be, does the total births per woman depend on the literacy rate? So get used to looking at the graph and asking yourself that question. So this graph shows a negative trend. So as you can see, it's kind of going in a downward trend instead of an uphill trend. So this is showing that as the literacy rate increases, the total births per woman decrease. Okay, so here's another graph talking about trend. So we're looking at the two variables, age and time. And this is running times. So the question would be, does the running times depend on age? But because this graph shows no trend whatsoever, so if you look at the graph, it's not going in an uphill or downhill. It's kind of just like all over the place. So there's no trend. So it's nothing that we can predict from looking at this graph. For every age group, we cannot predict the time. So the last kind of trend that you might see looks kind of like this, where it's not positive, it's not negative, it's not a no correlation either. There definitely is some sort of correlation because, as you can see, there is a pattern to it, right? It's decreasing, and then all of a sudden it increases. So maybe it could be like, maybe the amount of corals in the ocean are decreasing, and then all of a sudden it's going to increase because maybe humans are being more proactive about the environment and how it's affecting corals. So all of a sudden the amount of corals in the ocean starts to increase. That would be great. So that's an example of something like this, but it's not linear. So something like this you wouldn't be able to describe with what we're going to proceed with in Chapter 4. You would just say it's neither positive or negative. Okay, so the next thing we're going to talk about after trend is the strength of an association. And scatter plots with large amounts of scatter or vertical variation indicate a weak association. But right, the closer they are together and the more linear of a pattern you can see, it's going to be strong. a strong association. Okay, so here's your example 1 talking about the strength. So your first graph on the left, as you can see, we're trying to figure out, does weight depend on height? The second graph is asking, does weight depend on your waist size? So is there a stronger association between height and weight, or between waist size and weight? So based on the 2 graphs, it shows that the weight tends to have more of association with waist size than it does with height. You can see that the second graph, the clusters are more together and it's showing more of a linear pattern. This one, yes, it does show a linear pattern with some association, but the second graph is stronger. Okay, so last one, after trend and strength, last one is shape, which is pretty simple. You're just basically looking, is it linear or is it not linear? So this one here is talking about, does zombie searches depend on vampire searches? So as you can see, the trend or the shape is pretty linear, and this trend is positive, right? And the strength is pretty strong. So now looking at this graph, it's talking about, does the ozone depend on the temperature? Not to say that there is no association here, but it's changing. It's not linear. If it was linear, it would be going more of this pattern, but because it's kind of like it's staying constant and then all of a sudden it's changing, it's creating a non-linear graph. Okay, so just to recap, when you write a description of scatter plots, you're going to discuss the trend, shape, and strength. Also, in addition to that, any observations that don't fit. So for example, an outlier, you'll see if there's like a point way out in the top on the right side or way on the left side, you're going to discuss that as an outlier. So if you were creating a scatter plot and you were making observations on it, if you do see an outlier, you should definitely not disregard it or ignore it. Your job is to figure out why the outlier is there. What is it coming from? Why is it an outlier? Is it a mistake, or did you just make a new discovery? Okay, here's example 2, describing associations. So let's look at this graph. What's the question that we're trying to answer? Well, it's saying, does the median age of marriage for men depend on the median age of marriage for women? Okay, so we're going to discuss trend, strength, and shape. So first, let's talk about trend. So is it positive, negative, or no correlation? Well, you can see that it's going in an uphill direction. So we'll say that the trend is positive. So in fact, I'm not only going to say that the trend is positive, but I'll say women who marry at an older age tend to marry men who are an older age. Okay, so let's talk about the strength. Would you say that it's strong or weak? Looking at the cluster of dots, it's really linear and clustered tightly together. So I'm going to say that the association here is strong. So I'll say that the association is strong with little variation. And lastly, let's talk about the shape. Well, is it linear or non-linear? It's linear. So we'll go ahead and say it's a linear association. And that's how you would go ahead and describe a scatter plot. Okay, so when describing associations, make sure to always use phrases like tends to. Just because there's so much variability in these scatter plots, right? It's not perfectly linear. They're all not lining up to be 100% linear. So you're going to use words like tend to. Also, we're talking about just 2 variables here, so one affecting another. And this is not talking about all the other variables that might be affecting the one. We're just focusing on 2 of them. So you would have to use words like tend to. You can't say, for sure, this is affecting this, right? Also, make sure to point out data points that appear unusual. So we talked about this before. So outliers, make sure you talk about unusual outliers or patterns that you're seeing. Okay, so here's 4.2. Measuring strength of association with correlation. So we're going to find and interpret the correlation coefficient. This always happens. I don't know. Sorry, you guys. Like, my PowerPoint looks great, and then when I start my video, it like gets all crazy. So sorry that that's happening, but that says find and interpret the correlation coefficient. So what is a correlation coefficient? It's a number that measures the strength of a linear relationship. So we're only going to be talking about strength in this section, not trend, not shape, just the strength. And we use this symbol R to represent correlation coefficient. It's also sometimes referred to as an R value. And it's always a number between -1 and +1. Values close to -1 or +1 indicate a strong linear association. Values close to 0 indicate weak. So why is it between 1 and 1? Well, because if you're at, let's say, a positive correlation, +1, this is meaning that 100% of your values are matching up. It's correlating 100% linear. And it's going to look like this, right? 100%. There's no variability in your values. So up until this point, when we're talking about strength, right, all we were saying is that it's either strong or a weak association. But the question is like, how strong or how weak? And now we're putting a value to it. We're giving a numerical value to give you tools to explain exactly how strong or exactly how weak of an association. Okay, so here's what I mean by R values that are +1 and -1. So if you look at the first graph right here, it's talking about does height depend or does height in centimeters depend on height in inches? Well, obviously, but anyways, that's why it's showing a R value of 1, because all of these dots line up exactly in a linear way. So we can say definitely strong, right? 100%. Height in centimeters, yes, depends on height in inches. The correlation is strong there. And in your second graph here is talking about, I'm not sure, C2, C1. So it's a negative correlation. Everything is lining up and in a downward negative slope. So if you have a negative correlation, remember that's not no correlation. It's showing that as the C1 increases, the C2 is decreasing, and that's lining up perfectly. So it's a strong correlation. Actually, a strong negative correlation. Okay, so let's see how we can visualize the correlation coefficient. So this first graph here talking about does weight depend on height. You can see the clusters are kind of tight, right? But it's not lining up exactly, but you can see this linear trend here. So the R value is 0.72. So it's positive, right? And it's more than half, more than 50%. So it's pretty strong. The second graph right here, does private income depend on city or government income? You can still see that it's going in some kind of a positive direction, but there's a lot of scatter to it, right? There's a lot of variability. So our value is 0.48, which is kind of a weak association. Your last one, does math SAT scores depend on GPA? This one shows an even weaker association, right? It's 0.19, which is close to 0. And as you can see, it is really hard to determine, right, that it is going in any kind of linear way. If we looked at this graph without seeing this R value of 0.19, we might even say that it's no correlation. It's not linear at all, right? So now you should be able to get an R value and in your mind already picture what the graph looks like, right? If your R value is a negative, and if then you should see a negative slope. If it's positive, you should see that. Looking at the number, the value, if it's like positive 0.72, you should have a picture in your mind of kind of how it looks like. Also, vice versa, if you're looking at a graph, you should at least be able to kind of estimate what the R value is. This way, just like how we did with histograms, right, you can verify your answer. If you get an R value and your graph does not match that at all, well, something went wrong, so you should go back and check it. Okay, so how to compute the correlation coefficient or the R value? Well, data is converted to z-scores, which are then multiplied together. These products are then added, and the resulting sum is divided by n minus 1. So I kind of like that. Should I show you guys this? Because I showed my in-person classes how I calculated the R value. But really, you would probably never calculate the R value by hand just because it takes so long. It's a long process. And because it's so long, there's a lot of room for error. So the best thing to do is to just put your data into a Google spreadsheet and have it calculated for you. But anytime you have some sort of formula you're working with, you gotta kind of make sure you understand it rather than memorize it, right? Just because, like, if you just memorize it, you don't really know what's going on. So you know what, I'm gonna show you guys just one point for this correlation coefficient calculation. Okay, so let's say this is 1 point in my scatter plot, right? And maybe I might have 100 points, but this is just one of them. So the x and the y values, x might be here at 68, and then y might be here at 160, and this is that 1 point we're talking about, and there's a scatter of like 100 of them. This is just the calculation for 1 point. So in order to do any kind of calculation for this correlation coefficient, you first have to find the mean of the x values, the mean of the y values. You also have to find the standard deviation of the x values and the standard deviation of the y values. If you guys remember standard deviation, that is super long in and of itself. So that's the first step you would have to do. Once you do that, then we're going to calculate the z-score for this x value of 68 and then the z-score for the y value of 160. So here's a review for z-score. So I'm going to do the z-score of the x value. So I want to find z-score of 68. So I'm going to take that, subtract it from the mean, which is 64, divide by standard deviation, which is 2.608. This will give me a value of 1.53. So try to remember, where is the z-score of 1.53? So it's a little bit past 1 standard deviation above the mean. Right? Okay, so now let's go ahead and calculate the z-score for the y value that we're trying to find, which is 160. So 160 minus the mean of the y values of 135, divide by that standard deviation of 26.73. This gives me a z-score of 0.94. So 0.94 is above the mean, but below 1 standard deviation. Okay, so look back up at the formula. What I did was I first found the z-score of the x value. Now I found the z-score of the y value. So now the next thing to do is we're going to take the product of those two. That's what the numerator is showing. So I'm going to take the product, which means I'm going to be multiplying 1.53 times 0.94. This gives me a value of 1.44. Okay, so this is just 1 point. Once I do this for all of the points, whether it's 10 points or 100 points, I'm going to take this, right? I'm going to have either 10 of these numbers or 100 of these numbers. And in my numerator up here, it says to find the sum of. So I would add all of those values and then divide it by however many values I have minus 1. This is like kind of averaging out, right? Like averaging out all those z-scores so that you can get that number, the strength, like how linear is it lining up. So this is how you would calculate it. This is what I mean and why it's going to take so long. And I would never ask you to do this for my class, and I would never advise you to do this for any correlation coefficient calculation. So we're going to do that with Google Sheets. So here's the data that we're going to be working with. You have this same chart or table in your notes. It shows heights and weights for 6 women, and we're going to compute the correlation coefficient. We're also going to make a scatter plot graph for this. So go ahead and pull up the notes and copy and paste this table into a Google Sheet, please. Okay, so once you have your Google Sheet up and the table has been copied into your sheet, you should show your 2 columns with height and weight. So once you do that, you're going to go to an empty cell. Here's the empty cell I went in, and you're going to enter in equals and CORREL, and it'll pull up that first parenthesis here for you. And since we're working with 2 different variables, you're going to be highlighting them separately. Okay, so once you have this entered in, you're going to highlight your X values, highlight all of that, and this is mine right here. Then you're going to enter in a comma, and then you're going to highlight the Y values, and that's going to show in a different color. Mine's in purple here. Once your cell looks just like mine, it should look just like that. Close your parentheses, press enter, and this value should come up. It should be exactly the same as mine, so about 0.88. Right, so this is a R value that's relatively strong. 0.88 is pretty close to 1. So this shows that the association between height and weight is pretty strong. So height depends on weight. Okay, so stay in the same sheet. We're going to use this same two variables to make a scatter plot graph. So follow, I'm going to just ask you to pause the video, right? And then follow these steps and create a graph. Once you create a graph, I'm going to ask you to customize it to add a little bit more to the graph. So if you follow the directions, your graph should look just like mine. And on the left side here in this chart editor, I just screenshotted what yours should look like when you hit trend line. You should have use equation in there, and you should have show R squared checked as well. So the equation will pull up here. We'll talk about that later. And then we have show R squared that shows up right here. So it won't show up the correlation coefficient, but it'll show R squared. So right, if it's R squared, if you just go ahead and take the square root, because that's the opposite of squaring something. If you square root 0.776, it will come out to our R value, which we previously got of 0.88. Also, this trend line that's showing in here, you should have that in your graph, because we're going to also discuss that in the next section. Okay, so here's some notes for correlation coefficient. If you change the order of the variables, like if you just switch them all around, it's not going to matter because it's still going to plot right where it's supposed to go. Adding a constant or multiplying by a positive constant doesn't affect it. So like if you are, let's say, you have something in inches, but then you all of a sudden want to convert it to feet. So if you add, or multiply or divide every single value by that same amount, it's not going to affect the R value, right? It's the strength of it is not going to change. R is unitless. R is only useful to measure the linear trend. Always graph your data first. So it has to be linear. You cannot find an R value for something that either has no correlation or has a non-linear trend, and makes sure that it's linear first. So always graph it first. And that's the end of section 4.2. Make sure you can get that graph and the correlation coefficient in your Google Sheets, because that's going to help you for your Pearson homework. And heads up, it's going to help you for your quiz 2 that's coming up.